Hello, my name is Richard Lüpken. I'm from the Berlin Institute of Health, and today I will tell you about a tool we wrote, BCMap, and it maps linked read barcodes to a reference. So first thing we want to know, what are linked read barcodes? And linked reads are basically short reads, but in a pre-processing step, large molecules are separated into small groups and then marked with a barcode, which can then be retrieved after the sequencing step. And as a result, reads from the same large molecule are marked with the same barcode. However, multiple molecules can have the same barcode, and we only have a low read coverage per molecule. So if you wanted to do something like a local assembly, you would have to gather multiple barcodes from the same genomic position. And that's basically what we do when we say we map barcodes. We actually map a set of reads that is represented and identified by a common barcode at the beginning of the read sequence. So we take this set of reads and then we find the corresponding position of the reference genome. And this can be used for any kind of targeted evaluation approach. For example, you could use this, as mentioned, for a local assembly. You map all barcodes and you retrieve the barcodes for a specific spot in the reference. And then we also provide a barcode index, which can be used to quickly retrieve all reads belonging to a barcode. So the alternative to this would be to do a complete read alignment and to cluster the read alignments first by barcode and then by their genomic position. So how did we do this mapping? We use a open addressing k-mer index, and then we go through the read files and we collect all reads of a barcode. And then from there on, we work on this read set. So this can be parallelized easily for every barcode. And we also did that. And what we do then for all reads of barcode, we query all minimizers of those reads from the k-mer index, and then retrieve the positions on the reference for rare k-mers or minimizers, which do not appear too often on the reference. We sort these hits by their position, and then we use a sliding window approach and a quality score to determine the best mapping genomic windows. And we can see that down here. The score consists of every k-mer in the window, of every k-mer hit in the window, and it highly scales with the abundance of this k-mer in the reference. So very rare k-mers are weighted much higher than more frequent k-mers. And also we take into account the active time of the minimizer. So the more sequence is covered by one minimizer, the heavier it is weighted when calculating the score. And for the sliding window, we can see here, we are using two break criteria. First of all, the maximum gap size. So for example, this lone k-mer hit not belonging to any window does not belong to any of the neighboring windows because it is too far away from the next k-mer hit. And here we can see an example for the maximum window size. So this k-mer hit does not belong to this window because this one would provide a bigger score, and the window would have be larger than it is allowed to be if it should contain both of those hits. So we then, as a result, get a list of possible mapping windows for the barcode and a score for every single one of that. And we can also filter them by a length, so we do not trust too short windows. And the score can be used as an assessment of the likelihood that a mapping is correct. We compared the performance to a read alignment with BWA and long ranger, and we can see that BCMap works much faster, of course, because we do not align every read, but we map every barcode as a whole. And however, we have to state that for long ranger, the time also includes the pre-processing of the link read data, because this could not be done with the tool we used for BWA and BCMap. And to show the accuracy, we compared it to long ranger. And here we have to state that neither BCMap nor long ranger, of course, knows the real truth. So even though I'm talking about recall and precision, we have to be aware that we are talking about an agreement between these two tools here. And we can see that BCMap and long ranger largely agree on the results. Of course, for the long ranger data, we had to cluster the alignments based on their genomic position to retrieve genomic windows, such as we did. And we did this for different scores. And for a higher score threshold, we only allow, of course, reads that are more likely to be correct. And we can see that in the data, we have a lower recall when compared to long ranger, but this is only a slight drop. And we have a much steeper incline in precision. So what we intended with the score actually came through, and a higher score resembles a higher likelihood of a barcode mapping to be trustworthy. Thank you for your attention.